Okay, good morning everyone and welcome to Theta Stage. Today we have 5 awesome speakers for you. And we will begin shortly with the first one. Just some information for you guys. If you have any questions for those of you watching online, just type them in the chat and we can address them at the end of the speech if we have some time left. And for those of you who are here on site, you can also do that if you do not prefer your face to be seen for some reason, or you can just raise your hands and we will address those questions. Cool. Also some information for you guys on site. Don't forget, today is the greatest after party of them all. All information is in the program or in your badges, or you can just ask me and I will let you know how to get there. And okay, so let's dig into some great content and let me introduce you to the first speaker today. We begin with some AI stuff and we have Håkan Silfvernagel. He's from Norway. And Håkan holds a Master of Science degree in Electrical Engineering and Master's degree in Leadership and Organizational Behavior. Håkan is a Microsoft MVP in AI and a Microsoft Certified Trainer. And in this talk, Håkan will give an overview of affective computing and how it can be applied in order to make our interaction with machines more suitable to us as humans. So here's Håkan with Affective Computing, bringing humans and machines closer through emotions. Stage is yours.
Thank you, Tia. Yeah, thank you so much, and thank you to everyone who came here physically in person, and also to all of you who are watching this online. So I would first like to tell you a little bit of a story here. So a couple of weeks ago, I wanted to buy a new printer, so I went to the store, so I bought this new printer, and then I came back home and I installed it, and then I just tried to print a document, but it didn't really work at all. So I thought that was kind of strange. So I was trying to, do some debugging, trying out is everything connected and so on, and it was, but it was still doesn't print. So then next thing, I go to YouTube. I try to find a video that explains how should you actually connect this, and I check, yeah, that seems to be working okay. And I also did, maybe what you're not supposed to do, but I was actually looking at the instruction manual, but not even the instruction manual, it didn't work here. So what do I do then? Then I was checking out, is there any contact information so that I can actually, maybe I can call someone at this store or maybe at the manufacturer. So I found the manufacturer site and there was no email, but there was actually a chatbot. So I thought, oh great, I can use this chatbot and probably get some help on how can I connect this to get it online. So I was talking to the chatbot, but the chatbot was giving me just very generic answers back. It didn't really answer my specific question on my specific problem here. So then after a while I got really frustrated, and at one time I actually wanted to throw both the PC and the printer out of the window. So the question is, can we avoid these type of situations? And the answer is actually yes. So today I'm going to be talking about affective computing, how we can bring principles from psychology in order to build services and products that are more suited to us humans here. So Tia was covering my background here, so I'm not going to repeat that, but if you want to reach me or if you want to follow me on social media, you can find all of my links here on this slide. One thing that I would like to touch upon is that I'm quite active in the local user group community in Norway. So I'm an organizer for the Norwegian.net user group. I'm also running Oslo AI, which is focused on AI. I'm running a virtual user group in Sweden, Azure User Group Sweden, and I'm also the co-founder of an online AI school called AI42. So if we have time at the end of my talk, I'm going to present a little bit about this AI42 school. But the topic here is affective computing. So maybe you wonder, what is it? So we can say that a short explanation is that affective computing is sort of the human side of artificial intelligence. But we can also have a little bit longer definition. Then we can say that this is the study and development of system and devices that can recognize, interpret, process, and simulate human effects, and that is human emotions here. So basically it is, how can we use emotions in order to have a better interaction, both with machines and services, but also between us humans. So in order for us to be able to understand this, we first need to cover a little bit about the basics about what is actually an emotion. So we're going to be covering a little bit what we know from psychology here about both about emotions and how we can do in order to detect and study emotions. So first of all, we can distinguish between 3 different types here. We both have emotions. So emotions, they are a fast automatic response and they are temporary, and what it is, it's a react to a stressor. And as we will see here further in my presentation here, emotions are common to all people. And then we also have something that we call feelings. So with feelings, we have to involve our cognitive awareness. So that means that we are aware both of the environment and it involves a thought process. And feelings is a long-lasting process. And then finally, we can talk about mood and affect. And mood and affect is a complex situation here, because then you have both feelings and emotions working together. Now I'm going to go through some theories of emotions where researchers or psychologists have tried to explain what is sort of the inner behavior or inner functions of us in order to understand our own emotions here. So I'm going to go through the James Lange theory of emotion, Cannon Bird, Schachter Singer, and then Lazarus. So our first theory of emotion is called the James Lange theory of emotion, and this theory dates back to the 1880s. And what these 2 researchers said was that we see an external stimuli, and that leads to a physiological reaction. And our emotional reaction is dependent on how can we interpret this physiological reaction. So an example here is you're out in the woods and you see a grizzly bear, and then you will have a physiological reaction. Your body will start to shake and tremble, and your heart will start to race. And according to this theory here, they are saying that we will interpret this physiological reaction, and we will conclude that we are frightened. So that means that we are not trembling because we are frightened. It's the other way around, that we are feeling frightened because we tremble. But if we think about this a little bit longer here, we can see that this can't really be correct, because that means that all of the emotions that we can experience, we need to have like a physical counterpart to that. And that was also obvious for people at this time here. So they came a challenge to this theory in the 1920s from Cannon Bird. They said that we feel both this emotion and the physiological response at the same time. So in the brain, there will be a signal that will result in a physiological reaction. So you will see a snake, and then at the same time it will be that you feel afraid and you begin to tremble. But the thing here is that people experience the same type of physiological response to different types of emotions. So an example of that is, an example of that is if you, for example, sweating and heartbeat and respiration, they are the same, regardless if you feel fear, excitement, or danger. And in this model here, we can see that both the emotion and this physiological response will be independent of each other. Then we have something called the 2-factor theory of emotions, or the cognitive theory of emotions from the 1960s. And in this model here, we focus on the interaction between 2 factors, both the physiological response and also our cognitive labeling of that response. So an example here is you're alone, you're in the parking lot, and then all of a sudden you see a strange man walking towards you in the parking lot. And then the following will happen. The first thing is that you see the strange man appearing, you can feel your heart start to race and you tremble, and then this rapid heart rate and the trembling are caused by fear, and this is something that we call a cognitive labeling. And then you conclude that you are frightened. And then the last theory is a theory from Lazarus. This is called the cognitive appraisal theory from the 1980s. And what Lazarus said is that in every situation we are doing first a primary cognitive appraisal, and that's basically you ask yourself, what does this situation really mean here? So you can come to the conclusion that maybe what you're experiencing is not so important, or maybe it's a good thing, or maybe it's a bad thing. And then after this primary appraisal, you do secondary appraisal. So it can either be positive appraisal, then you tell yourself that, I can actually do this if I do my best, or if I fail, I will just try another method. But it can also be a negative appraisal, and that means that you say, I can't really do this, I know I will fail, and I won't even try because my chances are actually too low. So an example of this is you are again out in the wood, you see a bear in the wood, and your primary appraisal will be, oh, this is very stressful. But then you can have secondary appraisal where you say that I can actually escape. So that's the way that this model works. So now when we know sort of the basics here of what an emotion actually is, then we can start to talk about how can we actually measure emotions. So in order to understand this, we need to go back to the late 1800s. Then we had Charles Darwin. He wrote a book called The Expression of Emotions in Man and Animals. And in this book, he claimed that emotions are universal across the human species. And he also claimed something that was quite controversial at that time. He said that emotions actually had an evolutionary history. And we will have a look at these claims here in a short while. And then around the same time, in the 1860s, we had a French physician called Duchenne. And what he did, that he was studying facial expressions and emotions. And he wanted to write like a book where you could have different types of photographs of facial expressions. And then he wanted to couple that to a specific emotion. So he did a lot of experiments here where he had these subjects. He induced a small current in the facial muscles so that he could cause a facial expression for his test subjects. So in this way, he managed to sort of provoke 60 different discrete emotions, and he wrote a book about it. And as we will see here forward, this was some groundbreaking work actually. And then we fast forward here to another 100 years, and then we have an American psychologist called Paul Ekman. He was studying facial expressions and emotions, and he wanted to know if this claim that Darwin had, that all of our emotions and facial expressions, that they are actually universal. So in order to find out if that's true or not, he traveled to Papua New Guinea to study the facial expressions of an isolated tribe. And then he actually found here that facial expressions and emotions are actually universal. So that led him to write a book here that we call the Human Atlas of Facial Expressions, as you can see here. And this book is still used here today for behavior studies. And basically what we can see here is we can see something called micro expressions. So we have small small muscles in our face that will get reacted when we experience an emotion here. And he also came up with something we call the universal emotions here. So we can see here 9 types of emotions that we call universal emotions that every people on this planet can experience. So the question is here, how can we actually do in order for us to detect what type of emotion we have? So first thing that we can do is what we can see here in this slide. We can do facial studies, and we can also do bodily expression studies on that. Or you can also analyze the speech. You can analyze both the tone, the pausation, the rhythm, and the intonation of a speaker. Or you can use physiology-based measures. And here you can measure the EEG, or the heart rate, or the skin conductance, for example. So now when we know a little bit more here about both what an emotion is and also how we can measure emotions, then we can actually start talking here about affective computing. So affective computing originates here from the middle of the 90s. So there was a researcher here at the MIT Media Lab called Rosalind Picard. She wrote a book that's called Affective Computing. And by writing this book, she actually started a whole new field of research. So by now, this field of affective computing has its own IEEE proceedings, and also international research conferences and multiple research groups all over the world. And what she said here in her book was that we should be able to recognize the emotional state of the user by using both sensor, by using cameras, by using microphones, and also using machine learning like speech recognition, gesture recognition, image recognition, and so on. But at this point in time in the 1990s, all of this sounded very science fiction-ish. because of the state of the both the hardware of the PC and the state also in machine learning here. So she actually got quite criticized at that time. But as we know, now AI and machine learning is a very hot topic, and the question is what has happened since the 1990s up to then. So what has happened is that we've had a number here of enabling technologies that allows us to use machine learning. So for example, we have smart sensors and IoT that allows us to get real-time data, to both get a lot of data and get it in real time. And we also have solutions for big data solutions, both in the cloud here, so that we can handle these large amounts of data and do the transformation and the things that we need to do. And then we have machine learning algorithms that actually we as software developers, we can actually call just by making an API call. So that means that in a way we can say that machine learning has been more democratized because we no longer need to have a PhD in mathematics or in statistics. It's enough for us to understand what is sort of the input to the machine learning algorithm and what do we get back out and how can we interpret that. So as long as we can make an API or REST call, then that's sort of sufficient here for us. So we have if you take the Microsoft suite of services, we have a number of different services that we can divide into three main parts. We have the AI services, the AI tools, and the AI infrastructure here. So what I'm going to be focusing on here in my talk is the AI services, and more precisely here on some pre-trained services. So that means basically that you have machine learning algorithms that you just can use out of the box in form of these cognitive services. So here are some examples here what we can do with our Azure cognitive services. So we have solutions here for vision, to do face recognition and identification. We have speech transcription, speech to text and text to speech. We have language detection, language understanding. We also have some knowledge functionality and some search. But what we're going to be focusing on today here is the face recognition and identification, and also something called emotion recognition here. So I can also say here that this is not unique here for Microsoft. So we also have similar services from AWS and many other type of providers here. But at least here in the Microsoft case here, we can use something called the face detection API, and then we can recognize these following type of emotions here. So the input to this machine learning algorithm is an image, and in this image you can have one or several persons, and then the machine learning algorithm will do an estimate what type of emotion is this subject experiencing. So if you have a look in this here, for example, the machine learning algorithm says that it's a 68% probability that this woman here is experiencing disgust, and we have 93% probability that the child here is experiencing a surprise. So now I'm actually going to show you how we can do in order to set this thing up. So let me switch here over to the Azure portal. So here in the Azure portal, in order for us to use this, the first thing that we need to do is we need to define a face resource. So if we so if we create here a face resource, then we just need to, as usual, we just need to define in which resource group do we want to have our resource. We need to define a name for our resource and a pricing tier. And after we've done all of that, what we will get back here is a test console. It's a test console here, and in this test console we can use this to make some initial tester just to test out that we actually get some results back that makes sense to us. So in order for us to test this, then we need to just define what is the name here of our service that we want to call, and we need to define it that what we want to get back from this Azure Cognitive Service is the face attributes, and more specifically the emotional face attributes. And then after that, you have a subscription key, and then you can define here, then you can define an URL to an image that you want to have analyzed. So right now, we have some images. One more. We have a couple of images, actually the same images that we had here from before, and then we can specify here that we want to have like a first image analyzed here. So then if we do this REST call here, then the first thing that we get back here is we get a face rectangle. So that means that our machine learning algorithm has been able to detect that there is a face in this picture, and also the location here of the face. And then the second thing that we'll get back is this facial attributes. So here you can see the rating from our machine learning algorithm, and then it says here that with 80% probability this person here is experiencing a surprise. And we can do the same thing here for this woman, but I think what might be a little bit more interesting is here what happens here if we have several people here in the picture. Will our machine learning algorithm be able to handle that? So if we change our thing here, input here to the third picture, and then we send, then we can see here that now we got two facial rectangles. So our machine learning algorithm was able to detect that we have two faces, and we can see here that our first face is experiencing surprise with 99%, and then our second face here is experiencing a neutral expression here with 93%. So this is just, you know, a very basic example here, but you know, but you can build this out and as you wishes. But the basic here is what I want to show here is that you can use, there are many type of algorithms that you can use just out of the box, and which is just, you know, a REST or an API call away for you. So let me go back here to this. Now I'm going to talk a little bit about how can this actually be used in some more realistic application scenarios here. So one way that we could use this is in the retail industry. So you could imagine here that you have a store that is equipped with some web cameras or some cameras, and by using these cameras, you know, the store clerks can identify easily if a customer is irritated or if he's in a good mood, and he can adjust his service to take that into account and give a better experience here for the customer. And we can also talk about a medical scenario. So in this medical scenario, you could use this physiological-based measures that I was talking about in order to recognize the patient's emotional state and also be able to reduce, you know, stress, among other things. And by doing that, the medical team could provide a better service and respond much quicker to the needs here of the patient. And you could also think about the school situation here in education. So the teacher could use cameras to have a quick check here about sort of, you know, maybe the average emotion in the class of the students, and then he or she could adjust the teaching style if he recognized that the children are feeling bored here. And this could also be used in an online setting where we could make use of the web camera in order to measure the emotions of remote students. And then in large parts of at least the Western world, there is a big problem here that we have a huge population of elderly people, but we don't have enough young people that can help them in their daily life. So in Japan, they have made experiments using robots to be able to socialize with these elderly people. And the way that they have done this is by both using facial recognition, using speech and tone evaluation, and also use these physiology-based measures so that the robot can adjust the behavior when they are interacting with these elderly people. So I would also like to take the moment here to say a couple of words here about what is actually here in the front line. So in the front line, we have a company that is called Affectiva, So Affectiva also stems back to the MIT Media Lab. So what they say is that they have the world's largest emotion database. They have millions of faces that has been analyzed across a lot of countries. And what Affectiva do is they offer us as developers both an emotion SDK that we can use and also an API so that we are able to integrate their products into our own products. And some examples of use cases where this has been used is, for example, to create a virtual assistant that can recognize the emotion of the user, so we don't run into this problem that I was describing initially with this printer and the irritation and that stuff. But you can also think about maybe you have a self-driving car and you want to be able to make a more personalized transportation experience. So this self-driving car could use this face detection and emotion detection in order to detect what kind of state are my passengers in. So for example, if the AI finds out that the passengers are in a bad emotional state, he could just take the shortest path here between 2 points. But if I finds out that they're in a good mood, maybe he will take the scenic route, and he could adjust the music and so on. And it has also been used in advertising because in advertising it's really important here to elicit the right emotion at exactly the right time. And it's also very interesting for the advertisers to do studies to find out what kind of emotions does our advert provoke. And another way that this has been used is they have done both face and head tracking inside of cars. So that way we can easily detect if the driver is getting drowsy. So then we can generate an alarm so that we avoid that there will be, a traffic accident. Then we also have Pepper here that I would like to introduce to you. So Pepper is a robot developed by a Japanese company called SoftBank Robotics. So they have focused on making robots that are adapted to humans. So Pepper was introduced in 2015, and he determines the emotions of the people around him, both by utilizing voice and face recognition and also body movements. And he can respond back both by changing the color of his eyes, the tone of his voice, and also the content that is displayed here on his tablet. And he's been used both in large banks in Japan, in Nescafe stores, and also in the railway stations in various places in Japan. And also a fun fact here is that the software that Pepper is using is actually this Affectiva SDK that we were looking at here previously. So the next thing that I would like to talk about here is something that's called artificial general intelligence. So artificial general intelligence is when you have a machine or an AI that can perform any type of intellectual tasks that we as humans can do. And that is in comparison to what we have now. So what we have now in the AI world is something we can call narrow intelligence. So that means that our AI can only work on a very specific problem-solving task or reasoning task. So throughout the history here, we have had some operational definitions for artificial general intelligence that we can actually try to detect when an AI can said to be have this artificial general intelligence. So the first test that we have here is the Turing test that was first described in 1950 by Alan Turing, and we also have a prize competition here. So in the prize competition, they say that the program will win $1 million if it can fool half of the judges into thinking that this is actually a human, while it's also interacting with them in a free-form conversation for 30 minutes and interpreting some audiovisual input. We also have something called the coffee test, and the coffee test is basically that then we would like to see an AI that can go into an average American house, and it should be able to figure out both how to make coffee, so that both includes identifying where is the coffee machine, figuring out what the different buttons do, and finding also the coffee in the right place. And we have something called the robot college test. That's when a robot can actually enroll in a human university and take classes and get its degree in the same way as us humans do. And the final test here is the employment test. And this is where an AI program has the potential to completely automate the things of task, all the kind of tasks that we as humans are performing. So now the question that we can pose to ourselves here is, what does this say here for the future? Is this a threat or is it a hope? So we can have a look here at what some previous thinkers have said here about this. So first out here we have Elon Musk. In 2014 he said that with artificial intelligence we are summoning the demon, that AI is actually our biggest existential threat. Then we had Stephen Hawking around the same time. He said that the development of full artificial intelligence could spell the end of the human race. It would take off on its own and redesign itself at an ever-increasing rate. And humans who are limited by slow biological evolution couldn't compete and would be superseded. And we have a guy that is called the father of machine learning, Marvin Minsky. He said already in the 1970s that once the computers get the control, we might never get it back. We should survive at their sufferance, and if we're lucky, they might keep us as pets. And around the same time, we also had some other AI researchers, Alan Newell and Herbert Simon. They were claiming here that something called the symbol systems modeling human problems solving is the answer. And they said, we must alert the people here, but they didn't really need to alert people. This symbol system modeling was not, something that was very threatening here to us. But it could be interesting to have a look here at what does, the leading researchers among AI and machine learning, what do they think here, both if this superhuman artificial intelligence will appear, will it be a good thing or will it be a bad thing? And also when will this actually happen? So there's a researcher at MIT, Max Tegmark. He sent out a questionnaire to the leading AI researchers asking these questions, and this is the result that he got back. So if we're thinking that this artificial intelligence superhuman will appear here in a few years, that's virtually no one of the leading researchers that think that that is the case. But if we're talking that it will occur in a few decades up until 100 years, then we can divide the research community into three bigger groups. So we have both some people that we can call the Luddites that think this is definitely a bad thing, and we have something that we can call the digital utopians that thinks it's definitely a good thing, and then we have the majority is somewhere in between that we can call the beneficial AI movement. And then we also have the last group is some people that we can call the techno-skeptics, and they believe that this will actually not happen in the next 100 years, or maybe it will actually never happen. So another thing that could be important here and that I'd like to touch upon is ethical AI. So there is a test here that has also been administered by the MIT Media Lab called the Moral Machine. And by now there are millions of people across many different countries that has taken this test here. So the test is that you have a self-driving vehicle that is approaching a zebra crossing where there are people crossing, and then the question is, what should this self-driving car do? So should it prioritize humans over pets, or passengers over pedestrians, women over men, and so on? And an interesting question that you might ask yourself is, should the car actually take action or not? Because it could also be the case that maybe the self-driving car is saying that this situation is much too complex that I can't make a fair decision over this. So what they found here in this study is that there are huge differences here depending on what type of culture you belong to. So we can see here that countries with a more individualistic culture, like the United Kingdom and the US, they are much more likely to spare the young people than people from a more group-oriented culture like Japan or China. We can also see that individualistic cultures are more likely to spare more lives. Like, for example, it's the same here, the UK and the US versus China or Japan. Or sparing pedestrians over passengers. Here we can see that there's a big difference between Japan on the one hand and also China on the other hand. So the question here is, we could see that there were large differences depending here on what type of culture we belong to. And that raises an important question here, because a lot of people are talking about, AI and ethics, like that is something that is that we can set some sort of universal standard here for an AI. But as we can see here, if we as humans can't really agree on what is the moral or ethically right thing to do, then how can we then assume that something that we've actually made, that thing should be able to set some objective standard here for what is morally or ethically right. So what is important for us here is to recognize that this cultural differences will impact both the way that we develop our machine learning algorithms, the way that we are using the machine learning algorithms, and that there will also be bias. There will be bias both in the data that we have used in order to train the ML algorithms, and also in the way that we're actually using it in everyday life. So a way for us to reduce this bias is trying to find some sort of framework that we can use, both in order to detect that here there is obviously a bias, and then that we can actually do something about it. So one of the tools that I would like to talk about here is a tool called Förlearn. So Förlearn is actually an open source toolkit, but it's also built into the Azure machine learning suite of tools here. But you can also use it as a standalone tool here. And what Förlearn does is that it makes us easily recognize that there is some sort of bias here or a harm. So we can distinguish between two different types of harm here. One is a type of harm that we can call a quality of service harm. An example of this is you have a voice recognition system that might not work as well for women, for example, as it does for men. Or you can also have another example is a system here for screening loan or job applications that might be much better at picking good candidates among white people, white men, than among other groups. So if we open up this tool here, we come to visualization dashboard, and here we can decide here which feature would we like to evaluate our model, the fairness of our model. And in this example here, we take gender here as our feature that we would like to have an evaluation of. And then we need to set some sort of quality or performance metrics, and here we take accuracy as the performance metric that we want to use. And then we can see here, so actually the case here is that you have both women and men, and they want to take a loan here, and the question is, will they be able to take the loan or not here? And if we have a look here, there is difference here. If you see on the right hand side that 21% of the male applicants, they will actually get this loan, whereas only 6.35% of the female applicants will get a loan here. So basically we can say that it's around a 15% difference in something we call a disparity rate here, and that's not good here for us. So we want to do something about this. We want to be able to mitigate this disparity. So one way that we can do this using this tool, the Förlearn tool, is we can relearn our machine learning algorithm here. We can create a new model. We use something called a fairness constraint, and in this case here we're using a constraint called the demographic parity constraint. And by doing this, we can see here that finally, after we've done our training, we get a selection rate which is much more fair. So in this new updated model, we get the male have a 17% chance of getting this loan, and the female has a 15.5% of getting the loan. And then we can also, what can also be interesting here is we can compare our initial model with our new updated or mitigated model, and we can see what the change in disparity has to say and how it affects our accuracy, because it was the accuracy here that was sort of our quality goal here, or the way that we measure success here. And then we can see we can compare the mitigated model with the previous one, and we can see here that the accuracy has been reduced from around 84% to 82%. So it's a small amount that that has been reduced, but the disparity has been reduced from 15%, which was the original one, which was the problem, down to 1.63%. So I would say that this is a pretty good trade-off here. So so this is a nice tool here, both to detect do you have any skewness in your machine learning models, and it also allows you to actually do something about it. And as I said here, this tool here, the Fallon tool, is actually integrated with the Azure machine learning suite here, so you can just use it from the Azure portal. So now, finally, I would also like to talk a little bit about the concept here that is called collective intelligence. So collective intelligence is nothing new here, but it's been known for a long time that if you have a group of people, you will have a much higher chance of getting great results than if you have a set of individuals. So some researchers set out to find out, is there any specific factor that we can find that we can call a collective intelligence. So they were making studies here, and then they found, because maybe your first idea is to think that maybe you should just bring people with a high IQ, you know, smart people together, and that will lead to good results here, but that wasn't the case. It was only moderated correlated with this average IQ in the group here, but instead they found 3 other factors here. So the first factor is something that is called the average social perceptiveness, and this is a test that you can do yourself. So the average social perceptiveness is a test of reading emotions just by studying, you know, the eye portions of a face. So so you should in a way be able to read the emotions just by studying the eyes. So that was the first factor. And then the second factor that was important was the participation in group conversations when they were solving these different problems. Then they said that it was really important, it was sort of democratic, that every participant in the group were able to speak up his or her mind, and that you didn't have any dominant part in the conversation here. And the third one was actually the proportion of women in the group. So they said the more women, the more intelligent groups in this test here, and that you could relate that back to this average social perceptiveness, because on average women are better than men on reading these emotions through the eyes. So basically what this is telling us here is that for us as individuals, we should have great interpersonal skills in order for us to work together, and we can also use this affective computing in order to make these products that are enabling us to work better together here with machines. I hope if you found this interesting here. I also have some references that you can check up on your own. So the first reference is this Affective Computing book by Rosalind Picard, and then we also have a book called The Blueprint for Affective Computing by Klaus Scherer and Tanja Bensinger, and we also have something called the Oxford Handbook of Affective Computing by Calvo, De Mello, Gratch, and Kappas. Yeah, so with that said, I would like to thank all of you, both here in person and also all of you who are watching online, for attending my session. And if you have any questions here, you can always reach out to me on my Twitter handle, which is Gravlis, or you can use this email address that we have on this slide. So thank you so much.
Thank you, Håkan. Now, do we have any questions here? You can just raise your hand. Yeah. Let me just bring your microphone so people online can hear us.
Hi. Thanks for the talk, by the way. So, you demonstrated fairly... Am I being heard?
Fallon, yes.
Oh, okay, fine. So, you demonstrated with Fairlearn an example of equalizing to try and mitigate the difference and the bias. But the bias sometimes, well, in non-controversial issues, I guess, or in non-controversial dimensions, is justified because it comes from the training set.
Yes.
So, I mean, and also extrapolating, isn't that, in a sense, favoring simple, discrete functions over, you know, complex, nonlinear outcomes, right?
Yes. Yeah. So yeah, thank you for the question here. Yes, I think it's always important that that we as responsible developers take sort of the driving seat or take control here, because so Fallon is just a tool that we can use, but it's not, maybe in some cases it's not the right tool to use, and in some cases maybe we need to do a much more thorough investigation of what is the actual problem and try to think about what are the consequences. Is this actually the right thing to to do this kind of mitigation that we did here? So I think it's the important thing here to take into account is that just because a tool exists, it's not always right to use it. That we need to use it with being aware here of what is the consequences of what we're doing.
Okay, thank you. Will there be another question? Okay, so I have one of my own, Håkan. Can you think of which industry currently could take the most advantages from AI but isn't doing it so?
Yeah.
Could it be medical, medtech, or educational sphere?
I think I mean, yeah, it could be maybe in the medical sector here is probably a good candidate, I would say, because in the medical sector, you can probably have the opportunity to actually save lives by using AI. And I think that's a very important thing here to do. So maybe it has the greatest impact in that sector.
Well, and since our theme this year is future, and you already spoke a bit about future, but what's your personal thought? Is AI a threat, or is it going to be an amazing thing?
Now, for me, I think AI is more of a tool. So I know that some people, they get very frightened when you talk about AI, but then I usually try to ask them, what if I ask you what is 5 plus 3 or something? Then of course people are not frightened about that, but you can also you could argue that AI is a particular kind of mix here of mathematics and statistics. So AI in itself is not so threatening. It's just more the way that we use it, that we need to be able to use it in a responsible way. And I think what is important here is that in order for us to be able to use it, then as many people as possible should actually be able to know what is AI and know what can it be used for, so that we can actually have a public debate about should we use AI for this or for that. So I think that's the most important thing going forward, I think.
I think it's also worth to remember, when electricity was invented, people were scared of it too, massively. So maybe this is the thing. So thank you again, Håkan. Once again, a round of applause. We have a little gift for our speakers, so our volunteer will bring it, and we will be back here in about 10 minutes' time.
Yes.